Okay, how you guys doing there? We got one more video here before the semester's up. Section 3-8. Now, this is not going to be on your exam, but we are going to have one more homework quiz during exam week. I'm going to cover Section 3-8. I'm making this video actually on Sunday. What is this, about this 5th or 6th? I don't know what the date is today. But I'm going to post this video on the 10th. That's this Thursday. And then you'll have until the following Thursday, December 17th, when we'll have our homework quiz over. So it's one last score that we're going to have. On the next day, December 11th, on that Friday, if not even earlier than that, I'm probably going to post even earlier than that, a review sheet. We will have a review sheet to cover the exam. So I mainly want you to worry about the exam over the weekend, next weekend. And we have our exam, remember, on the 14th. And then once you take your exam on the 14th, you still have like the 15th, 16th, and 17th. You can get this assignment done. So anyhow, just trying to get a little ahead of schedule here. But this is the last new material you're going to have for this semester. We're not quite done with trigonometry. Usually I try to get all of trigonometry done the first semester, and then do the functions and statistical stuff for FST. The second semester, but we're a little bit behind because of the whole situation we're in right now. So anyhow, we probably have another 3 weeks or so of trig, and then we'll get into the other stuff. So anyhow, we're going to cover Section 3.8 today, and it's similar to Section 3.7. It's not quite as easy as 3.7. I don't think it's much harder, though, than Section 3-7 was. Hopefully you thought 3.7 was pretty easy. Should have been. We're still doing trig equations. If you look at the worksheet, Section 3.7 says trig equations part 1, and Section 3.8 says trig equations part 2. Okay, so we're going to continue on. It's more algebra basically, and you'll need your unit circles. Also, I will give you a unit. That's what I'm looking for here. I will post on Schoology a unit circle that you can use on your exam, so you will be able to use that because you will need it for a few problems. So anyhow, you're going to need your unit circle for this, so you might want to get that out if you haven't already got it out for Section 3.8. So anyhow, when you look at the worksheet on 3.8, it goes from, I apologize, it looks like when I copied it, something, I don't know, smudged a little bit there. There's a couple of bars at the bottom of the paper that you can see. I don't know if you can see that or not right there down at the bottom. That it makes it kind of hard to see, but I think you can still make out most of it. So anyhow, we always skip questions 1 through 4. So if you look at this, it goes questions 5 through 68, or yeah, we're not going to go that far, anywhere close to that far. If you want, these are ones you could cross out. Cross out questions 15, 16, and 20. 15, 16, and 20. And then also cross off 23 through 28, all of 23, 24, those last 6 questions, 23 through 28. And then on the back, you could cross off number 37 and 38. And then the last question we're going to do is number 40. So everything after 40 you can cross off. So on the back, cross off 37 and 38, and then 41 all the way to 68, cross all those off, okay? So let's go and dive into these. So again, we're just doing more algebra, okay? Just with trigonometry stuff. So if you liked algebra, you'll like this, okay? So let's look at question number 5, okay? Question number 5, where'd that come from? That's a 2, duh. How about question number 5 on section 3-8? Okay, so they give us 2 cosine squared. That's where the 2 came from. 2 cosine squared plus cosine equals 0. I should put thetas in there, but you don't necessarily have to. I'm not going to mark it wrong if you don't, okay? So we can't solve this one right now. I mean, we can, but it's a little bit tougher. I mean, what's different? I mean, if I gave you something like this, 2x squared plus x equals 0, that's a quadratic. Let's go back to algebra here, okay? We haven't talked about this stuff in over a year, okay? It's quadratic, second degree. It means it's going to have 2 answers, okay? So what we need to do is well, how do you solve quadratics? Quite often we factor them, okay? If you also could use a quadratic formula, completing the square, bunch of different things, okay? We're going to factor this thing. So if I want to factor this, I just pull out an x. So over here, I'm just going to pull out a cosine. Cosine times what gives you 2 cosine squared? 2 cosine. Plus cosine times 1, okay? So either this is 0 or this is 0. So we say cosine of theta equals 0, or 2 cosine theta plus 1 equals 0. So I solve this, I subtract 1 to each side, and then I divide by 2. If I do that, I'm going to have cosine of theta equals negative 1/2, or cosine of theta is 0, okay? And then we just look at a unit circle, okay? Where is cosine 0 at? Well, and we want these in radians, not in degrees, okay? Cosine is 0 at pi over 2. as well as at 3 pi over 2. And then cosine's negative 1/2 in a couple spots, okay? If we look where cosine is negative 1/2, it's negative 1/2 at 2/3 pi, 2 pi over 3, and at 4 pi over 3, okay? At each of those values, we have cosine negative 1/2. Now, we said we're supposed to have two answers. We have two answers for cosine, but cosine always has two answers for any value. So we're actually going to have four answers, okay? If it was just an algebra problem, it would be two answers. But since it stands for a trig function that has two answers each, there's four answers altogether, okay? So we need all four of these, okay? Pi over 2, 3 pi over 2, 2 pi over 3, and 4 pi over 3, okay? Let's look at question number 7. Number 7 is very similar to question number 5, I think. Okay, you'll see. 2 sine squared minus sine, 2 sine squared of theta minus sine of theta, minus 1 is 0. Okay, we're going to factor this. Now, we can't factor out a cosine or a sine here because this has no sine on it, okay? Now, you might want to think, well, let's add 1 to each side, then we can factor a sine out. Yeah, but when you factor, it's always got to equal 0, okay? So, we're going to factor this thing to make 2 sines. If it was 2x squared, it would be 2x times 2x. Well, this is 2 sine squared, so it's 2 sine times sine. And then our last term, remember we ignore the middle, we look at our last to make a negative, it's a positive and a negative, and it makes a difference where I put the plus or minus on this one, because my first terms are different. I'm guessing plus minus. That's a good guess, okay? Now that little trick, if you remember from algebra, you times to get this and add to get that, only works if that's a 1. That's not a 1, okay? That's a 2. So to times to get 1, there's only one way, 1 times 1. And we check it by doing our outers and our inners. Our outers, negative 1 times 2 is negative 2 sine. My inners is 1 times sine, which is 1 sine. Together that's a negative 1 sine, and that's what we wanted, was a negative 1 sine. Okay? So either this is 0 or this is 0. So either 2 sine plus 1 is theta, plus 1 equals 0, or sine minus 1 equals 0. If we solve this, I'm going to subtract 1 to each side, and then divide by 2. If I do that, we subtract 1, that's going to be negative 1. Divide that by 2, you get negative 1/2. Or add 1 to each side, you get sine equals 1. So we look at a unit circle. Where is sine 1 at pi over 2? And where is sine negative 1/2? Back here it was cosine negative 1/2. Where is sine negative 1/2? At 11 pi over 6 and 7 pi over 6. So those are our answers. 7 pi over 6, 11 pi over 6, and pi over 2. Okay? All right, let's get rid of this over here. Okay. What was next? Just did 7. Let's look at number 9. Number 9 is an easy one. Okay. Tangent minus 1, secant minus 1. And this is nice because it equals 0, and that's good. And it's already factored. It's already factored for you. So either this is 0 or this is 0. So tangent minus 1 is 0, or secant minus 1 is 0. Well, we add 1 to each side. We get tangent equals 1, or secant, add 1 to each side, secant equals 1. Now, secant is 1. I'm going to flip that. I don't like secants, okay? Flip secant, you have cosine. If you flip this, you got to flip that. Well, if you flip 1, it's still 1. It doesn't matter, okay? So, where is tangent 1? There's two spots where tangent is 1. Tangent is 1 at pi over 4, and tangent is also 1 at 5 pi over 4, okay? And cosine is 1. Cosine is 1 at, now be careful on this one, okay? If you look at unit circle, you might say, well, cosine's 1 at 0 and also at 2 pi, okay? Well, they're the same spot, okay? So when we put 0 or 2 pi, does it matter? Yes, it does. It does matter. Read the instructions, okay? It says on the instructions, your interval is from 0 to 2 pi, including, which one does it include? It includes 0. So you don't get to put 2 pi. 2 pi is not inclusive. It's got to be smaller than 2 pi. So you need to put 0. Okay? So just make sure you read the instructions. Okay, number 11. Okay, this is where they start getting a little more fun, I think. Sine squared minus cosine squared equals something. 1 plus cosine. Okay. Now this one looks a little tougher because they're mixing things. Now you got sines and cosines, okay? This is not factored, okay? So we want to make everything the same, okay? You either make everything sines or make everything cosines. I'm going to make everything cosines for the simple reason there's more cosines than sines. So I only have to switch one thing. Okay, what is sine squared, okay? Remember, sine squared plus cosine squared is 1. So sine squared is 1 minus cosine squared. Minus cosine squared equals 1 plus cosine. Okay? Because sine squared plus cosine squared is 1, so 1 minus cosine squared is sine squared. Let's clean this up. We have 1 minus 2 cosine squareds equals 1 plus cosine. Okay? This is still a quadratic, so it should equal 0. I'm going to move this to this side. So I'm going to subtract 1, add 2 cosine squareds, add 2 cosine squareds. If I do that, this side turns to 0. These are gone. We're left with 2 cosine squareds plus cosine. Okay? And then we could factor that, or we could be efficient. I looked at this, oh man, this looks familiar. 2 cosine squared plus cosine? We already did that. Okay? So I'm just going to say C number 5. Now, if I ask you for that one on a homework quiz, okay, don't write down C number 5. You go back and look at number 5 and you write down the answers, okay? We're not cheating here. We're just being efficient. We already did the problem. We're not going to do it again. We don't need to do it again, okay? All right, next one. That was number 11. This doesn't erase real well, I think. I wonder if this doesn't erase very well because it's freaking cold in here right now. I'll tell you what. I'm actually here on a Sunday morning. I think they turned the heaters off or something. Because I am freezing and I'm always hot. Well, you guys knew that though, right? Bad joke. Okay, number 13. Okay, sine squared equals 6 times cosine plus 1. Okay, so again, I want to make everything the same. We just said that sine squared is 1 minus cosine squared. I'm going to do that. That way everything's cosines. So 1 minus cosine squared equals, let's go and distribute that, 6 cosine plus 6. Let's make it equal 0. I'm going to make this side 0, so minus 1, add cosine squared, Okay, these cancel, so we have 6 cosine squared plus 6 cosine plus 1, or plus 5. Okay, and let's factor this. Okay, cosine squared is cosine times cosine. Positive is plus plus or minus minus. There is no minuses, so plus plus. There's only one way to make 5. 5 and 1, and that works. Say times to 5 and add to 6. So, I'm not going to write this part out. You should be able to do this in your head, I would think. Okay, either this is 0 or this is 0. To solve this, if this equals 0, cosine would be negative 5. I'd subtract 5 to each side. Or, to solve this here, I would subtract 1. Or cosine equals negative 1. Well, where is cosine negative 5? Nowhere. Cosine's never negative 5. It's way too small. Okay? Where is cosine negative 1? Cosine's negative 1 at pi. Okay, so there's only one answer there, pi. Okay. 13, we crossed off 15, we're on to number 17. Number 17, every year I do this. I don't know how to do this one and show work on it, okay? And what I mean is this, okay? I would like them to be the same. Well, I can't make them the same. Sine and cosine are not the same. Now, if one of them was sine squared or one of them was cosine squared, we could do a substitution like we did back there, but I can't make them the same. We can't really factor it because there's nothing common to anything here. So, I mean, how do we do this one? This one is so easy. It's just I don't know how to show the work on it. This is simply saying, where is sine and cosine the same? Where are sine and cosine the same? We look at our unit circle. There's two places where cosine and sine are the same. At 45 degrees, at pi over 4, okay, they're both radical 2 over 2. And the other place they're the same is at 225 degrees, 5 pi over 4. They're both negative pi or negative radical 2 over 2, okay? I mean, they're the same. I don't know how to show work on that. I really don't. I don't know if there's a possible way of showing your work on it. It's simply asking you, where do you look at on a unit circle where sine and cosine are exactly the same? Now, yeah, be careful. Some students might say, well, how about at 135 degrees, 3 pi over 4, they're the same. No, they're not. They're opposites. Okay? All right. Next one. 17. Number 19. Okay, question number 19. Tangent is 2 sine. Tangent of theta equals 2 sine. Okay, so here's what I'm going to do. I'm going to make tangent to sine over cosine. Okay, That's better. That way we have some signs. They're not all the same though. I'm going to clear my denominators. Okay, I'm going to times each side by cosine theta. Okay, these cancel. I'm left with sine theta. And this we're going to have 2 times sine theta cosine theta. Okay, and I'm going to subtract this to each side. I'm going to subtract 2 sine cosine. So I have sine of theta minus 2 sine theta cosine theta equals 0. And I can factor this now. I can factor out a sine. Sine of theta times 1 minus 2 cosine theta equals 0. So either sine of theta is 0, or this right here, 1 minus 2 cosine theta is 0. Subtract 1 to each side. It's negative 2 cosine theta. It's negative 1. Divided by negative 2. Divided by negative 2. Cosine theta is positive a half. So either sine of theta is 0 or cosine of theta is 1/2. Okay? So we look at our unit circle. Where is sine 0? Sine 0 to a couple spots. At 0 and at pi. And where is cosine 1/2? Cosine's 1/2 at pi over 3. And at, what is it, 5 pi over 3? 5 pi over 3. Okay. All right, that one's done. Okay, 21. 21. I think I can squeeze this one in here. Got to be careful on this one. This is an easy one, but it's also a tricky one. Sine equals cosecant. Sine equals cosecant. Well, cosecant is the same as 1 over sine. Okay? I'm going to clear my denominators. I'm going to times each side by sine. If I do that, sine times sine is sine squared equals, these cancel and you have 1. Okay? So sine squared equals 1. So, now be careful here. I mean, what I could do is I could square root. You say, oh, the answer's 1 then. Where's sine 1? Gotta be careful. When we square root, don't forget the plus or minus symbol. So this isn't saying sine is equal to 1. It's saying sine equals 1 or negative 1. Don't forget the negative. That's where it was tricky. Easy but tricky, okay? So, where is sine 1 or negative 1? Sine is 1 at pi over 2. Sine is negative 1 at 3 pi over 2. That looks like a negative sign there. Sorry, I just made a mistake. I didn't make a mistake. I just made it smudge. Okay, so at pi over 2 and at 3 pi over 2, sine is 1 as well as, or negative 1, not as well as. Okay? All right. I think we're on the back now. 21, yep, 22. Okay, so 1, 2, 3, 4, about 5 more to go. 29 is the next one, 29. So we have 1 plus sine equals 2 cosine squared. Okay, so cosine squared, well, is the same as 1 minus sine squared. Okay, so 2 times 1 minus sine squared. Now everything's in sine. That's nice. Distribute by 2. So we have 1 plus sine. 2 times 1 is 2. Minus 2 times sine squared is 2 sine squared. It's a quadratic, so make it equal 0. So I'm going to move all this over here. So minus 2 minus 2. Add 2 sine squared. Add 2 sine squared. We have 0 on this side. Put it in the right order and combine like terms. 2 sine squared plus sine minus 1. And let's factor this thing. So 2 sine squared is 2 sine times 1 sine. Have we done this? Man, this looks really, looks familiar. To make a negative, it's either plus minus or minus plus. I'm going to make it minus 1 plus 1. If I do that, if I do my outers, I get 2 sine. My inners is negative 1 sine. 2 and negative 1 is 1, so that worked out okay. So either this is 0 or this is 0, so sine is negative 1 if I subtract 1 each side. Here, sine would have to equal add 1 and divide by 2, so sine is 1/2. So sine is negative 1 at 3 pi over 2. And where's sine? Positive 1/2. Sine is positive 1/2 at, what is that, pi over 6 and 5 pi over 6. So all of those, okay? 31. 31, we have 2 sine squared minus 5, 2 sine squared minus 5 sine, plus 3 is 0. Okay, this one's a little bit nicer for a few reasons. One, it's a quadratic. It already equals 0. That's good. And everything's in sines. It's all the same thing. So let's factor this thing. 2 sine squared is 2 sine times sine. Last term's positive, so it's either plus plus or minus minus. We've got to get negative somehow. And to make 3, it's 1 times 3. There's only one way to make 1 and 3, or 3 is 1 and 3, and it makes a difference where I put the 1 and the 3 because my first terms are different. This thing went to sleep. I just want to make sure we're still going here. Yes, we are. Good. Okay, so it's either 1 and 3 or 3 and 1. I'm going to guess 3 and 1. If we do my outers, that's a negative 2. My inners is a negative 3. Together, that's a negative 5. So either this is 0 or this is 0. Add 1 to each side. Sign is 1. Here, add 3 and divide by 2. If you do that, you get 3 over 2. Where is sine 3 halves? That's the same as 1.5. Where is sine 1.5? Nowhere. It's too big. Biggest sine ever gets to is 1. Where is sine 1? At pi over 2. So that one wasn't too bad. Okay. I think these are, I don't know, they're a little more work than the last worksheet, but I don't know, to me the last worksheet was kind of boring. They were so easy, you know. Very little work you had to do, which, I mean, it's nice to not have to do a whole lot of work, but kind of boring questions. These are a little more interesting, I think. I don't know. Okay, that was 31. Okay, 33. So 33, 35, and 39. 3 more to go. 33. 33, so we have tangent. No, we don't. We have 3, 1 minus cosine equals sine squared. Okay. So I'm going to do 2 things here. I'm going to distribute on this side. I'm going to make my sine squared 1 minus cosine squared. So 3 minus 3 cosine. That way everything's in cosine. Quadratic, make one side 0. I'm going to make this side 0, so minus 1. Add cosine squared. We do that, we have 0 on the right. Combine like terms, put in the right order. Cosine squared minus 3 cosine plus 2. Let's factor this thing. Cosine squared is cosine cosine. Last term's positive. It's either plus plus or minus minus. It's got to be minus minus. There's only one way to make 2, 1 and 2, and it works because they times to 2 and add to 3. So add 1 to each side, cosine's 1. Add 2 to each side, cosine's 2. When is cosine 2? Never. When is cosine 1? Cosine is 1 at 0. Is it 0 or 2 pi? What did they say? I think it was including 0. Yes. So it's a 0. Okay, 33's done. 35 and 39. 35. So tangent squared equals 3 halves secant. Okay? All right, so we've known that sine squared plus cosine squared is 1. That's one I told you to memorize a long time ago. Hopefully you did. And then there's 2 other formulas that I honestly don't have memorized. I create it based on that. Okay? I'm going to divide everything by cosine squared. Divide by cosine squared. Divide by cosine squared. If I do that, sine over cosine is tangent squared. Cosine squared over cosine squared is 1. 1 over cosine is secant squared. So tangent squared plus 1 is secant. So if I minus 1 to each side, tangent squared is secant squared minus 1. So where I see a tangent squared, I put a secant squared minus 1. Why did I do that? Everything's in secant now. Okay? I'm going to make, I don't like fractions. I'm going to times everything by 2. So 2 secant squared, take away 2, equals these 2's cancel, 3 secant. Quadratic should equal 0, so minus 3 secant each side. So we have 2 secant squared minus 3 secant minus 2 is 0. And we factor this thing. 2 secant squared is 2 secant times, looks terrible, times secant. Last term's negative, so it's either plus minus or minus plus. I'm guessing plus minus, I'm totally guessing. To make 2, now times to 2 and add to 3, that doesn't work here. I mean, you think 2 and 1, they times to 2 and add to 3, but because that 2 right there, that doesn't necessarily always happen, okay? So it's going to be 1 and 2, and it makes a difference where I put the 1 and the 2 because my first terms are different. I'm guessing 1 and 2. If I check this, if I do my outers, that's negative 4 secant. My inners is positive 1 secant, negative 4, and positive 1 is negative 3, so that's good. So either this is 0 or this is 0. So if I subtract 1 and divide by 2, we have secant equals negative 1/2. Here we just add 2. Here we have secant equals 2. Now be careful. You might be in a big hurry to cross that out and say 2. It's too big, okay? We're talking about secant here, okay? Flip them. Secant flipped is cosine. Flip 2, you get 1 over 2. Flip secant, you get cosine. Flip negative 1/2, you get negative 2. This is the one you want to cross out. Cosine's never negative 2. Okay? But cosine is 1/2 at, where's cosine 1/2? Didn't we just do that? No, I guess we didn't. Thought we did. Okay, anyhow, cosine is a half at, what are we at, pi over 3 and 5 pi over 3? Okay, all right. All right, 35, 39, last one. This is real similar to the one we just did, I think. Okay. Okay, so 39, we have secant squared. Secant squared plus tangent 0. Okay, so secant squared. Well, we just did this. What do we have here? Tangent squared, secant squared minus 1. So secant squared plus, what do we say? Tangent squared is secant squared minus 1. So what is secant squared? We add 1 to each side. Secant squared is tangent squared plus 1. So tangent squared plus 1 plus tangent. Secant squared is tangent squared plus 1 plus tangent 0. I'm going to put these in the right order. Tangent squared plus tangent plus 1. You're going to hate this one for a second, then you're going to like this one, okay? So, we factor this thing. Tangent squared is tangent, tangent. Okay. And there's no negatives anywhere, so it's plus plus. How do you, and there's a 1 right here, okay? So how do you, that works, how do you times to 1 and add to 1? How do you times to get 1 and add to get 1? You can't. So how do you factor this? You can't. So does this have any solutions? Maybe, maybe not. We got to use a quadratic formula. That's the part where you're supposed to probably groan and say, oh, I hate this. Okay, so A, this doesn't factor. We're trying to factor something that doesn't factor. So A, B, and C. Now, if you hate the quadratic formula, it's really okay because it doesn't get any easier than this using the quadratic formula. A is 1, B is 1, C is 1. They're all 1. So negative B is negative 1 plus or minus the square root of B squared, which is 1 squared, minus 4 times A times C is 1 times 1 over 2 times A, which is 2 times 1, which is 2. 4 times 1 is 4. 1 minus 4 is negative 3. What's the square root of negative 3? Imaginary, okay? We're not dealing with imaginary numbers here, okay? So what real angle works for this? None, okay? There's no solution, okay? There is no angle that satisfies this, okay? All right, so that was done. So again, this assignment, I would, hopefully you're viewing this on December 10th. That's when I'm going to post this. But don't really worry about it until after the exam. I would get ready for the exam first, and then you have till next Thursday, the 17th, to fill in the ones that we skipped over, okay? If you have any questions, email me, and I'll get back with you, okay? Talk to you later. See you.